before I am implementing marching cubes, I'm just making a quick playlist here. My new Suno credits. Uh, Let me make like maybe 3 more batches of songs here. We're just putting in random combinations of genres. So I've narrowed down my workflow for making like background music in this. Just generate like come up with like a string of words and like a couple music genres you want to hear. Generate until you can't generate anymore, and then before you like solidify a playlist, like you don't even need to listen to these. If it comes out at 4 minutes, I just immediately delete it. Jesus, none of these worked. Every single one came out to 4 minutes. Well, that's a bummer. But that's why we generate bunches of them. So I just basically trash can every one of these that is the full 4 minutes, because they never end properly when it does that. And then you're left over with the winners from a given section of a prompt. I'm going to create one more suite of these, and then I'm going to put everything in a playlist and cull it and mix them around, and then I'm going to start coding. But I'll set this up first so that I got something to listen to while I'm doing that. And so I've been working on this algorithm. It's marching tetrahedra. So it's kind of similar to marching cubes, but it seems like it's just better. It generates more mesh per node, which is the only potential weakness. But if that's a problem, you could just like go up one node in LOD, I think, and it should be fine. Alright, so this one failed. Four, 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 four. It's like half of them. Like, so you're just immediately culling like half of your results pretty much. But like, it's not worth the time it takes to listen through these for the few gems that are going to come out at 4 minutes, because they're almost always fucked up when it does that, at least in its current state. All right, we're going to do one more of these, and um, upbeat pop synth under the sun. Get some nice like tonal contrast here, and this will be the last set of songs that we produce. So I'll just do until they're done. All right, that's as many as we can make, and then 4 minutes. Trash can. And then like it's still gonna produce some stinkers because it's AI. Like the majority of what it produces is a stinker, right? That's the whole thing, is that it doesn't matter because it can produce so much in a given time. So basically it just becomes like a vetting process past this point. We make a playlist, we listen to it a couple times. While we're listening to it, if we hear anything egregiously bad, we just go trash can it or broken. And then through natural selection, we end up with a sort of good background music playlist that won't get copyright struck. All right, come on, come on, come on, come on, come on. Yeah, like this is not very good. Very repetitive. But that's what I'm saying. Like you still have to call it. We're just waiting on the rest of these to finish. Let me strip out any of the ones that fail to finish under 4 minutes. Add these to a playlist and then mix them around so that we're not getting like all the same song in one go. All right. Very bottom. The playlist. Dream City. Where'd it go? There it is. All right. Silence. Okay, so Starflight Village, Stream Trance. Here. Here. Move you down. Up groove. Move you down. That's fine. Sunrise, move it down. And we're just manually shuffling, and then we're done. Sunrise, progressive metal. Atmospheric metal. almost done. And when you do it like this, you can produce a pretty good amount. Okay, this is trash can. In a pretty short amount of time. And it'll be like, okay. Now, if we took this list and we pared it down into like 10 songs, we would probably have like a bunch of bangers. Okay. That's good. All right. Let's get to work. Actually, let me get some water. Can't use Claude again till 1 a.m., which kind of sucks. See, we got it. Okay, no changes. This is the only thing we got left right here for the node. And then we have the wrappers, but the wrappers are not going to be as hard on this one. Because, okay, so this one has some advantages. And their advantages, some of the advantages could propagate out to other nodes. I think. I have to think about it for sure. Actually, no. None of the advantages we get on this would be applicable to our dual contouring implementation. And I think this might be, assuming this produces a good mesh, it would be fundamentally better in that in dual contouring, to build a quad or a triangle, we basically need to sample neighbor data, like we have to. So like to build a quad, for example, to build this quad, we would pick up this edge, which in our view, like this is a 2D, but in our view, it would be this center point here, right? And then around this edge, we need the neighboring nodes. And the fastest way to do that with an Octree is actually spatial sampling, because our spatial sampling is like ON lookup time. So what we would do is compute a little small offset, sample this node, sample this node, sample this node, sample this node, and then once we have those nodes, each of those nodes is going to have a vertex. And actually, the way we do it, we sample in a counterclockwise direction because we build triangles counterclockwise. So we'd sample here, 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 and then we would go the same order for our winding. So to build this triangle, with us sampling starting up here, going here, 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 here. So our triangle winding is the same way. We go here to here to here, back up to here for our first triangle. And then again, it's counterclockwise winding first. So that's triangle 1. Triangle 2 is from here to here to here to here. So for triangle 2, we go, again, starting at our start node, counterclockwise order down to this point, over to this point, and back up here, and bam, you have a quad. All right, and then the other situation you can find is you may find a situation where you have a T-junction with two nodes of a smaller wad and a single node actually, and a single node of a bigger wad. Now the logic to do this sample is the same. We pick up this edge, we sample counterclockwise in 4 positions, so here, 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 but we're storing unique nodes only. So this node got sampled twice, so it actually gets merged into one node, right? And then, so our sample ends up sampling 4 times, but our result set is this node, then this node, then this node. And again, each of these nodes has got a vertex in it. So we just connect in the order that we sampled them in, and we build a triangle. And then there's one other thing that we can demonstrate here, is what if instead of sampling into the larger node, we only get 3 nodes. If we were to sample this edge, we get 1, actually in order, 1, 2, 3, 4. So we actually get 4 nodes. And again, if we have 4 nodes, each node's going to contain a vertex. We connect them in the order we sampled them in. So it would be here, 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 here. And if you'll notice, this is like a continuous function. So like our mesh is contiguous across lot boundaries. Okay, so this is how we do it in dual contouring, right? And then if it's all the same size nodes, it's just like it's just a quad. So that's the basic idea in dual contouring in 2D, except in dual contouring we do it in 3D. So like, I'm not gonna draw that because it actually makes it harder to understand seeing it in 3D from like just drawing it. This is the basic idea. You take an edge, you act as if you're looking at the edge so that it's one-dimensional, and then you rotate around that edge in counterclockwise order, getting your nodes, and then you connect their vertices. Okay, so that's how our dual contouring works as far as meshing goes. It's good. It works pretty good, but it has some flaws, and so I started looking at other algorithms. One of the big flaws that I haven't found an elegant solution for is this can produce holes if certain scenarios occur, especially when you're dealing with like noise, like modified noise. So like say you have a sphere SDF or something. Hold on, I don't like this one, it's distracting. Okay, so where was I? You're always just iterating around the edges, and that means that every time we want to mesh something, we have to visit 3 nodes, and we can't just visit them directly. We have to traverse the tree to visit 3 nodes, which adds overhead as well. Not a ton, it's ON based on the tree depth, but it does add up. And for every piece of mesh we draw, we have to visit at least 3 and at most 4 nodes, which complicates things quite a bit. It does have the benefit of like once we figure out this formula, just easily producing contiguous mesh between blocks. Okay, so let's talk about the new formula that I'm working on. The new one I'm working on is called Marching Tetrahedra. It's a cousin of Marching Cubes, but it seems like it's just better than Marching Cubes. So basically, if you think of a cube, let's draw the cube first, just so that we can see what we're working with here. If we draw a cube, and we group every face of the cube into a face struct, and we calculate every corner point of density the same way we would with dual contouring, but then we make one more sample in the dead center of the cube, right? And then we take, so we've created 8 corners, 12 edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges, and 6 faces so far, right? So what if we took every corner point of every face and we connected them to this center point? Forming a little pyramid, right? So now we've built a pyramid out of the top here. We do this. And now we have each face becomes a pyramid, right? And we've added 1, 2, 3, 4, 5, 6, 7, 8 edges. No, wait. Is that right? I think I have my math wrong then. It's good that we're reviewing this. But basically now, instead of only sampling the nodes along the edge for densities, we sample the nodes along the edge and the center, and we have these tetrahedra. And we can track the surface crossing points on the legs of the tetrahedra. And it turns out that when you do that, no matter what, you at least get a triangle. And it's impossible to make non-manifold mesh. So mesh with holes. So this will be hole free, which is number one benefit. We were trying to figure out a good way to deal with holes in our other algorithm. This will do that for us for free. We'll never have to worry about holes. But this has one other really huge advantage. This does not require iterating surrounding nodes to generate mesh. For each node, we can generate mesh just for that node, and it will be contiguous with the surrounding nodes. So that's really, really good for us, because if our nodes are atomic and they're not modifying or reading from other nodes, then that makes the ability to parallelize our calculation of meshing value much easier to do, much, because each node can essentially have its own thread to calculate its data, and it doesn't have to lock any data or anything like that, because it's only operating within its own bounds. It's not reading from other nodes or anything like that. So if the tree changes, we don't care. but we would still have the problem of different neighboring water levels, the mesh not lining up. That's why we have one other optimization here that I came up with earlier today. Instead of reading the neighbor nodes to determine what their actual LOD is, we actually don't care. What we want to know is if I'm here and I did have a node over here, would that node be split? It should, given the node's virtual position and whatever the camera position in data is, if it could split, would it? And if we know that it would split, then we know that, for instance, this face should line up with another set of faces that are half its size. And so we need like LOD stitching on the geometry we generate within this within this tetrahedron. So that's really sick because it means that not only do we not need to check the neighbors to build our mesh, we don't need to check the neighbors to know if we should stitch the node or not. We just need to know if its neighbor would split given the current LOD. So what we do, according to the code, we have this should split and should split const vector virtual center, and I actually need to do something here, so we're going to fix it. So we make a should split method that works for our node, but we also make a should split method that takes a virtual center, which would be this, use our parameters of this node. So we use the extent and all that good stuff, tree index number, things like that from this node, but we're using an offset center in our calculation of the water level, which means that we can very easily check if our neighbors would want to split or not. And if they would, then we know we should stitch edges on that face. And then finally, so that we don't have divergent branches of logic, we're going to delete our old should split logic, and we're just going to invoke should split, but we're going to use center dot position, just the center position of this node, as our virtual center. So that way we can centralize the logic that calculates our splitting. And if we ever change this or want to try a different splitting paradigm, we just change it here and it will just propagate through all the rest of our logic. So the other part of this that's really cool is the fact that, so let's just draw a okay, I guess they don't have a sheared cube. If we go ahead and draw us a little tetrahedron. Alright, so the way we mesh is processed on a per tetrahedron basis, and if we have a volume that, say, crosses this corner, right? A sphere that's crossing this corner, then we can check densities, which we're doing anyway. So for instance, density out here is positive, and the density in here is negative. The density here is positive, and the density here is positive. Well, using these values, we can calculate or estimate the sign crossing points of these three edges. And then if we have these three edges as sign crossing points, we know that we need a triangle across these three edges. Likewise, if we have a sphere up here, we could do the same thing, but now we get 4 crossed edges, which can form a quad. Okay? So, like, each of these tetrahedron will generate a face if it crosses the surface volume. And the face will always be contiguous. So that's how that's supposed to work. And then the direction your winding order is determined by the face normal, probably. I'm not sure yet. I haven't gotten that far. But like reviewing this is good right now. Let's go check. So hang on. Oh no, it's right. It's right. I was just. It would be my tetrahedra structs. Oh no, it's fine. Each tetrahedra stores its connecting edges. So I think it's actually fine. Okay. Okay. Yeah. All good. So now we want to begin our meshing process. So the other difference between this is with the other one, we had to iterate at the Octree level to generate our mesh because we needed those edges and we needed to be able to like loop through surrounding nodes. We don't have to do that here. So each node is responsible for generating a little packet of mesh data. And then to like mesh a chunk, we just get all the surface nodes of that chunk and basically append all their mesh data together, and then push that into our stream, and then at that point we're good. I think. Right, let's take a look at some to-dos here. Alright, no to-dos in this file. What do you mean there's no to-do? I see it right there, motherfucker. Alright, so because Claude has been doing a better job at this, I kind of want to do the meshing once I can use that, which is only 30 minutes away. Because, like, that's, like, super fucking meticulous shit. But what we can do is we can run our current, like, we can code review our current implementation over here. So let's do that. So, okay, so I have been working on an implementation of marching tetrahedra country. Almost finished the Octree node clean. Then left is processing the actual mesh data from the Tetrahedra node. I would like you to review my implementation thus far. In particular, I would like to make sure that every time initializing the structural data of the node, I am picking correct usage of the static arrays in the Voxel structure structs. Have they ever released a new one? I guess not. I will post the two files. We need to make sure. Voxel structure first. Followed by Octree node implementation. Any code change suggestions, visible errors in logic. Optimizations missed. Contains position doesn't have a return? Really? He's fucking right. This is why we use a robot to code review us when we're programming on our own. No, we're not doing that. Potential use of indices in tetrahedron. Alright, I mean, this is pretty good. Like, this is the only bug it found. That's a pretty good endorsement because the AI is going to try to make suggestions no matter what. Like, none of these are really valid except this. This is valid. Who gives a shit? Like, once we get it right, we don't care if the numbers are hard to figure out. Suggested refactor? No, we're not doing that. Connecting it is for the indices. I mean, you just said they were, so like 2 seconds ago, so whatever. Ensure t-shirt unit are optimized. Yeah, this is more of like a Octree level thing. Yeah, this is like maybe if we were like if I was a AAA game studio, I would bang this out and then we might like iterate on like memory contiguousness for months afterwards, but it's just not, I don't have time to do that. Vector operations maybe, but like not really. I mean, I don't know if there's a midpoint operation, but co-op processing is at the Octree level. This is like a maybe, but I don't think that function is that expensive. Getting the changes. This is just telling me to test it. Yeah, none of this is super helpful. Alright, so do we build? Looks like it builds. Let's make sure we're up to date. Did should split loaded onto the base call, so check text retains position to actually return the value. know. Oh, right, because I'm on master. Okay, so I want to get set up because here in a moment, um, I'm gonna. We got 20 minutes to chill, maybe play a couple games of Magic, and then we're gonna hit. I think we can basically reuse almost 100% of the logic from our Octree and Actor wrappers. It's really this node that we're building that is like the primary bottleneck, and the next part is very fiddly, and it uses like the index tables, and I don't know how you're supposed to put that together. And I could figure it out, but it would probably take me 3 hours to face bash on it. Whereas if I wait for the thing that's been helping us do it, it's going to know how to use those tables. It's a shame. Claude is. I swapped out my ChatGPT for a subscription to this just for a bit, because I heard good things about Claude 3.7. I may switch back with the new models coming out of ChatGPT too, but this seems to have been it's pros and cons. So ChatGPT is better about remembering the shape of like your code and like the way your variables are named, the way your functions are named, and things like that. But Claude seems better at outputting actual good functional logic. Neither one are 100%, but they are helpful. So, you know, it is what it is. So I want to burn one. And then in a moment, I will be back. I really need like a text overlay for when I'm doing this. Alright, so I need some more water. I'm gonna go ahead and start it up and make sure it still runs. Quickly demonstrate the reason we're even building this in the first place, because our dual contouring implementation is actually pretty solid. It's just a bitch and a half to connect the holes. If I could fix the holes, I wouldn't need this, but alas, it's not that simple. And up close, when we have a high resolution, we don't get that many holes. But far away, the shit's riddled with holes. It's also not amazingly stable. Which I strongly suspect that the algorithm that we're working on right now is going to be a lot easier to stabilize and like a lot less fiddly with locks, because instead, like I was saying, instead of having to, as we're building the mesh, be constantly sampling surrounding nodes from this, which could change in other chunks and things like that. It's entirely internal to the node. So like the node can generate its complete mesh data with transitions without having to know anything about the nodes around it. And that means that if we run like get surface nodes, then we can do something like parallel 4 node update mesh accumulate data. Then outside that node, we can combine data into buffers. And then once that's done, for all the surface nodes, our update mesh data is complete. And once update mesh data is done for all the surface nodes, we can then do a P4 update mesh component. So we basically now we only have and shit for that matter, once a chunk is, well, no, yeah, it has to be like this. So basically at the chunk level, at the chunk level, person update one step on okay, at the all chunks level, P4 chunks, chunk in chunks, chunk, just some pseudocode. Update LOD recursive. Then when that's done, we can say chunk surface nodes equals chunk get surface nodes, and then we can, just thinking, P4, and that ended poorly. P4 kernel mesh data out data surface nodes num. We created an out data array. P4 node in surface nodes. Node update mesh data. Mesh data equals node or generate mesh data. Oh, actually, we don't even need to do that. We can just say internal out data at IDX equals node for generate mesh data, because this returns the mesh data from the node even if it doesn't do an update. And then once that parallel 4 is done, we can do a for internal mesh data in out data append to chunk RTM buffers. And then when that's done, update chunk RTM. And the nice thing about this is that all of the parallel 4s here, none of them are relying on synchronization outside of the thing that they're working on. So like here, we can synchronize at the chunk level, and here we can synchronize at the node level. This doesn't need synchronization because it's synchronous. This can be a parallel 4 too. Or actually, no. It's already in a parallel 4. And I think that is it. I think that is how this works at the Octree level. And then the actor level is basically just driving this with timers. Timer actor level, timer 1, other thread, timer 1. Inverts, chunk level, update odd, other thread, timer 2. Invokes, update, chunk level, update, mesh data. And these two just pulse at some interval, like we're doing in our current tree. I think that's it. And then, I mean, like, the chunks obviously will, or like the Octree level will be responsible for rendering the chunks, I think. But yeah, like, our wrappers are not too hard to make. It's really just coming up with this meshing function to fit with the algorithm, which is probably going to be pretty easy for the AI because it's just it's some usage of this table. I just don't know what the usage is yet. So voxel structure, there we go. Is this table here? All outside or all inside? V0. Is 5... Is 5 supposed to map to the vertex ID? Contrary corresponds to the case in the edge table. We may have to make an edge table. Oh no, here it is. Okay, yeah, I don't understand what that is. So, like, I gotta know how to use these arrays, but this is how we form our triangles. The AI is gonna know how to do that. I do think. So maybe clear our mind with a game of Magic. Oh, and I needed water in a bowl. And then by the time I'm done with that, it's gonna be time to implement. So I'll be back in a moment. Get. God damn, the season ended. I didn't even get Mythic. I didn't play a ton of Magic last season. Lame. I'll take that. That's a good card. That was pretty good, actually. Blue, red or green, blue or green. Creature spells. Wah, wah, wah. Okay. Alright, so burn one. Here we go. I'll tell an embarrassing story in a moment. Oh, and I need to take some painkillers, which are connected to the embarrassing story I'm talking about. So because we have the Barbarian, we're going to gamble right away, because we need to make efficient use of our mana here. Okay, well, we lose the Barbarian, so that sucks. Sure. That's fine. Now, if he erases it, we just concede. Alright, so just play this. Sure, we don't give a shit about our graveyard. Oh, I dropped my okay, well, I'm getting rid of the Charbelcher so that there's no danger of, God damn it, I dropped my lighter. Fuck. Okay, it'll have to wait for after the game. Alright, well, next. In turn. Dust, yeah, we don't give a shit. You're not gonna beat me by killing my graveyard here. A minute's lifelink, indestructible, can't attack or block unless there are 7 or more cards in exile. Whenever 1 or more cards are put in the exile or in the graveyard, draw a card. Okay. Resolve. So, do we want to just go ahead? I think I do. Get the mana so that if we top deck, we can just play it. Damn it, I can't believe I dropped the fucking lighter in the fucking couch. Son of a bitch. Okay, take 4 damage. Sure. Unfortunate. That's bad because I think we're just probably going to lose now. Felly eating our treasure is actually ridiculously bad for us. Pretty sure we're just dead because, like, we can't mana up to the point where we could do anything at this point. What answers do I have here? It would be like a bounce spell, maybe. We could bounce the character Tetramos. What's this? Enter Ephemerate. I don't understand what the Ephemerate is for. Yeah, we're dead. Alright. Scoop it up. You know, I actually did have an out there. I should have gambled for a the Barbarian that gives 2 mana, and I could have played it and had a chance of drawing a Ritual the next turn, and then with Ritual and Plunderers we could have gone off, but like it was super long odds. I dropped my fucking lighter and it fell in the couch. The couch ate it. I'm gonna get another lighter. We got mana, we got Belchers, surgical extraction. Looks good. Hello, friend. Alright, sure. Now, do we surgical extraction that duress? Or do we hold the surgical extraction for the Charbeltree is going to make us discard? He took the surgical. He has a bunch more duresses. I think that was the wrong play, personally, but... Sure. Go ahead. Yeah, okay. You're dead. Alright, getting later. Alright. So, all my grunting. So, till while nobody's in here. Embarrassing story, right? Last week, Saturday, I was walking my dog in the woods, and we'd had a bunch of snow. A lot of snow had melted and turned into ice, and turned back into water, and turned back into ice several times. So it was very treacherous. Sheets of ice. I'm walking a trail in the woods, not like super in the woods, but we have like a park and a little trail that goes through the woods. Oh, this is a turn 2 kill. So I'm walking my dog, and okay, sure. So I'm walking my dog, and I see a big patch of ice, and I want to walk around it. And a lot of times what I'll do to do that is I'll step in the snow around it, right? So I do that, except for what I stepped in was not actually snow. It was... Hold on, we need a mana up right here. What I stepped in was not actually snow. It was snow that had been saturated with water and had refrozen into white ice that is not flat like normal ice. It's still hilly, but it's like it was just a rock solid sheet of ice. You son of a bitch. You're so lucky, bro. Oh, I'm so lucky. Nice. That was pretty crazy hand of magic right there. Okay, so let me describe this fall. I wobble around. I have my dog in my dog leash in my left hand, and my feet are sliding down a hill of ice that I didn't know was there, so I didn't step on it like gingerly or anything. I just took a big ass step. Um, so I face plant. Actually, it's not face planting. I belly flop onto this uneven rock hard ice. I managed to hold on to my dog. My pants fell off. Um, and I thought that I had actually just broken a rib for a little bit. Enough to where I actually went to the doctor. I never go to the doctor, and it still hurts right now. So I go to the doctor. I'm like, I think I might have broken a rib. They were like, all right, let's take some x-rays. So he took x-rays, couldn't find a break, but it's been 7 days. That shit still hurts. It hurts to breathe. It hurts to sleep. It hurts to move around. So I'm taking some painkillers. But yeah, so that's the story of how I fell in the woods. My pants fell off, and I broke, or thought I broke, one of my ribs. I guess when I tripped, like the pants got caught up in one of my feet. The only saving grace is that this happened in the woods. So like there was nobody around. I'm glad it didn't happen in like the dog park. All right. We are green for coding. It is time. Here we go. Okay. We have implemented most of the new machine text for even Octree node. I think that the only thing left to do is the meshing section and generates mesh data for the node. This is on the meshing tetrahedra branch in GitHub. We need to somehow harness our meshing struct constant tables to properly mev our node. Date. Probably cache your node mesh data in the function of the F adapter of Octree node MTF the struct geometry. Clockwise. That happens, we need to So this is wrong because we already have the densities. So in geometry, we center operators are already sample position struct. Okay. So we don't need to I didn't even think about that, but we calculate midpoints now. And it's actually pretty dope, actually. Because we can use that for our lot stitching. Wait, why is it... I want the whole thing. Okay. This is compute and stitch. It wasn't too far off. All the density calculations would tank it though. Like, that's way too much. We're doing that every time we update the mesh? Hell, we don't have to do that. That's going to end up being our most expensive function, probably, when we put an actual noise pattern in this. We want to do that as little as possible. figure something out here. Can there be... Don't know why that's not. Oh, I do know why actually. There. Alright, so like this might just work. It's possible. Doubtful. We don't really have a good way to test it yet. Okay, now. Okay, so with that, we are done with the node, I think. Now, I'm going to leave Okay. We passed code review from our AI, from our AI, our fucking coworker. Okay, so both AIs are pretty happy with this. They both think it's gonna work. Maybe it will. So we've got this. Next up, the Octree. Yeah, I rolled a bunch of these functions into the node. Thinking thinking about how to handle the chunks specifically. Thinking if we want to handle it the same. I mean, we probably do. So I'm thinking about how we want to do this. Where's my chunk? Because like these might still be valid. Yeah, these actually are still valid. This is probably not needed for this. Yeah, see, like we're like reading all this stuff off this chunk node here that we don't even need to be doing. So like extent, center. It's like all this initialization logic in these is really nice, actually. Really useful. I'm just figuring out how we need to refactor it. So better double chunk extent, except for they equal. because we can reuse these mesh structs. I just got, like, there's some changes that have to happen because, like, this is tightly coupled right now with this Octree node, and so to do that, we're gonna have to break that coupling, and that means getting rid of this. Getting rid of this. This is more loosely coupled too, so it's quite good. So now we decouple this. It's gonna break in another class though, but it can work in both now because, like, this isn't storing, like, this isn't for storing, like, our actual mesh data. This is built as a wrapper to, like, basically translate it into the format it needs to be for the component we're using, which has some, like, very specific initialization requirements. All the rest of this may be valid. This is gonna be a little wrong. Need that. We want to get rid of everything from this that has anything that's not related to the real-time mesh stuff. We don't need this. This stuff can stay for now, but we really shouldn't need any of that. Alright, so this updates the mesh data. These two are good. This stuff. This stuff is important for the fucking. Where is it? Maybe in the node, actually. Let's just build it. Let's see what errors out. Oops. Nope. Get out of here. Yeah, see, like, this is a problem. Alright, so here's what we're gonna do. Here's what we're gonna do. We're gonna go here. We're gonna add the fucking shit back in. There it is. And then we're gonna find God damn it. What the fuck, man? Autocomplete failing. There it is. What? There's like a bit of like a mismatch. No, that ain't it. Builds. Alright. Alright, so I'm trying to think of the best way to do this. I'm not sure if the chunk map should actually live at the actor level. It would definitely be easier, but I guess we already have the initialization function to make it exist deep down, so why not? So our I'm just thinking about how we want to go about doing this, because like this next part is pretty critical. So we build out the key piece of what we need to do, right? But we need the like wrapping pieces that orchestrate it. And we already sort of have it over here, but it's a little different. So let's take a look at this. So far, I probably need all of this. All right. Root in chunks and mesh chunks. This would have a center and extent derivative off of it, right? So we take These four at the very least. It's just being extremely slow. You know, we can make this faster, right? If I close this down and reopen it, it'll help. So ow, that hurts. Oh, my fucking ribs. Okay. Material vector center double state. Initialize chunkos. Okay, so we know we want that. We know we're gonna need don't think we need to. Yeah, because like before we needed that because we were doing computations between nodes, but now we're not. So we shouldn't have to do this in a two-stage process where we like calculate the data and then update because we're waiting on like the neighboring nodes to like correct things. Now it's just like we call update mesh. It updates the mesh for that node and then or for that chunk and then just re-renders it. Yeah, so I think this actually can even go up here. Well, I don't actually need this. Yeah, that's a lot better. We only need the stuff that's like external actor shit. Okay, I don't have anything implemented yet. So, implement a constructor. Get rid of a constructor. Density function, center, extent. We need to look at this. did I set chunk depth? Oh, in it and chunk min max depths 3. So now we can do so split the depth. Next, we pick up the chunk nodes. Then we need to make get surface nodes. Okay, that's good. And then initialize mesh chunks. So this is a little different. So no, this isn't quite right. Yeah, so what happened to my shitty music? because this probably needs to change in the header. Yep. Okay. Go ahead and create a little definition of this. So one thing for each chunk in our chunk node. Awesome. We don't need this. This. This one was pretty bad. Right. Alright, seems reasonable. Now, because the chunks are not reliant on the other chunks anymore. Ooh. Good. You know what? I'm going to do a lot from in here. So for each chunk node, we're going to want to, if chunk nodes, IDX, pointer, it's static now, okay. I dig it. F, camera data in log vector. Boom. Alright, so that's our. Okay, and like we don't have to. This is so awesome. So we don't have to worry about like order of operations anymore either, I don't think. Yeah, we don't. It's actually insane. So because we're just guesstimating what the stitching should be, or not guesstimating, but like we're predicting if it should be a level lower, we now don't need to even update the whole lot of the tree to be able to stitch. So that leads to a much better flow actually, because we can say like, okay, if an update happened, right? If we successfully updated the lot on any node in this chunk, if we updated any of the lot of the chunk, then update actually no, we do have to do the full update lot because we need our. Okay, yes. So we update the WOD of the chunk. This is where we go. So we go here. We have Boolean WOD up B WOD. WOD updated equals true. Alright, so now we know the WOD is updated. If that's the case, this needs to actually be out of the scope. Alright, so we go through each lot, we update it, we flag the update to true. After it's done for this mode. Oh, okay. Yeah, yeah, it's fine. This is fine. Yeah, we can actually go for another here. It's like uh, chunk nodes, IDX dot generate mesh data. Chunk nodes, IDX. And what did we need? Now we want mesh chunks. We're gonna need a method in here. Inside the mesh chunk, actually. These two are good. We need to like add an adapter method, you think? Here's what we're gonna actually do. We're not gonna change this at all. But what we are gonna do is clone it. Move it over here. Take it back. This is gonna go in the Octree, I think. I don't need chunk edges. We do need chunk mesh data. All of this is legitimate. Initialize is literally just the same. We don't need any of these helper methods. This is all for like meshing logic stuff. We definitely don't need it. We won't update mesh data and we won't update components. Looks good. So what we really want here Wait, no way. Did I put it in the wrong fucking Octree? God damn it. Hang on. We may not need this. I'm gonna delete it till we do. Need this stuff though. Yep. Yep. Void. Alright, so we add this, right? And then this is gonna set up a mesh data. I guess we just have the chunk. The chunk has a string. Okay, so update from internal buffer. I'm in the chunk stream is what it is. So yeah, so we have access to chunk mesh data. But we want to build and swap, so we're gonna do it that way because like we can call this and go ahead and it'll call it's already got the copy constructor over here. So instead what we're gonna do is over here we just want to build an fmesh stream data Yeah, so we just gotta bite the bullet here. It's gonna be like, do we wanna, I think we do wanna copy over into the stream. It seems like that is the way. So we need to break out the stream. So do auto stream. So make an adapter layer. Something like this. We're gonna make these synchronous for now, but we're gonna author them in such a way that they could be made asynchronous. So just raw for loop. I swear the old-fashioned for loop is just the best one. It really is. It's the most flexible. So I is less than internal normals plus plus like this. Yeah, we have to deduplicate. Or do we? Let's see how far we get. So position stream set at I. We're going to set it to in turn buffer dot positions at ah. You can actually well, that's frustrating. I mean, sure. So we just make so we just change it and then save it. And then I bet the node is gonna break. It's fine. Yeah. Gonna filter MCs, delete, replace with nothing. And then it should also fix the problem in the Octree. Here it is. This is what I was looking for. What's my place? So All right, it's green, and then I do this, then so we got either of these could be parallel for loops too. We need to do this. Yes, it does. Son of a bitch. Stupid keyboard going bad. Alright, so wait, what? Fuck. Good work, technically. I'm so fucking confused right now. Let's overload this. Oh, wait, what? No, that doesn't make any sense. Let's just see if any errors pop up. Excuse me? I see. I know what's wrong. I'm just cross-eyed. It's getting late. F mesh instructs. Entry header. I'm just a little bit of a brainlet. There it is. Chunk. Accumulate the chunk buffer. That's the chunk buffer to the update mesh data. Update the component. Should be fine. Initialize the chunks. Alright, and now back over to... Alright, we're getting very close now. So now we just need... Right now we're doing this in update LOD. I don't know if it's right, but I think maybe we have everything we need. Okay. Let's see if it builds. We only got one more piece to build. Alright. Let's push it. First draft. Octree. First draft. Alright, so adaptive voxel actor is not a very big class. Yes, yes, yes. Actually, we'll do. Data. All right. Alright, so we set up our camera data, have our density functions here. We're gonna leave all of the things here, but we gotta change our Octree from the active to MT. doing a lot of this stuff, but okay. Something like this. And then if we go back over here, should be a lot happier. Alright, so this is our new actor, right? Update Voxel events. This whole thing here, sorta. Okay. Instructor. Actually, no, we're gonna leave them uninitialized for the moment. They're actually easier to track down that way. Looks like with those few minor changes, everything is happy. Let's see. So, got any more music down here? So we're almost there. So we're just gonna go one at a time. So virtual void on construction. We go over here to this guy because most of this is gonna be the same. We'll go ahead and do begin destroying on destruction. So we already have that stuff on. Let's do this. Close all but this. Open up this and this. And then also open up this and this. And get a little bit better organized. Okay, something like this. And then we have this, we have this. With this. Okay, beautiful. Now, over here, structure, adaptive, make shared, every type, sports Octree is fine. Begin destroy the right log, construction, on construction, initialize chunks. Okay, great. Back over here. Begin playing clean scene route. Okay, so far so good. Oh, this is, yeah, okay. Chunk mints. There it is. Nice. Okay. So orcs pay off here. Oh, yeah, that's right. I might not even need the second one with this paradigm. So we're just going to comment this out for the moment. Save that, go over here, comment it out. Alrighty, righty. So I think that might do it actually. So I guess let's give it a shot. Wait, what's the change here? Updates to actor. Alright, here we go. Holy shit. Come on. Let's see some mesh first time. Please. We build. Okay. We don't have any mesh, but that's fine. We didn't really expect to see mesh popping up the first time we ran this. So let's see. Are we pulling here? Yes. Okay. So we're just gonna go in. Mesh chunks aren't initialized. Let's try again. Oh, we got something. It's not right. But it's trying. So it's like not wrong is the thing. Like I was afraid when I ran this that it would be like, oh, this is just blatantly obviously wrong. but it's really not. Okay, that's not too surprising. We might not even need this anymore. Alright, I think I'm gonna go to sleep. This is good progress. Um, actually, hang on. I want to save the scene with the new test object and close it down so that it'll actually persist. So that I don't do what I just did there. Alright, so clearly our meshing is not correct. But like that's something we can definitely figure out what's going on with. We probably just I have my suspicions that it didn't necessarily order all these buffers we've been working with the correct way. Yeah, it's definitely not connecting the triangles correctly, which is fine. We will figure it out. It's fast, but it's not going down very far, so I want to figure that out. So no. This is why. is why, that is why. And min max. Now we get to see performance. All right. We were just getting the min as the max step. This should be substantially denser. It's not going to be meshed right. But you can kind of see that it's trying. Not as well optimized as we were with the other one, but that's like, there's a lot we can do to optimize this from where it's at right now. And we only have one level of parallelization going on with the chunk nodes, but like we can parallelize pretty much everything this does. Okay. Alright, that seems to me to be a pretty good jumping off point for tomorrow. What I am going to do, actually, is I'm going to go over here to our actor settings. And, like, this is more than we need, so let's do 6, or even 4. And then, I think this might be more than we need with this as well, which we knew we may be getting, like, more geometry. So, this is the last thing I really want to try. Big gains tonight. Lots of good work done. We're like 75% of the way there now. If we can make another 10% tomorrow, we'll have fully generating meshes, and then it's just going to be like optimizing. Okay. Hang on. I do actually. Hold on. This is like the main savings that we get actually. It should be pretty easy to add in. That's not gonna work though. We have to like. Or would it? No, it wouldn't. Um. Uh, we could make a. Let's talk to Claude. Okay, I'm optimizing now. Since all chunks, since our nodes, randomly, I'm gonna change this to a parallel form, but right now let's populate reference, and that is gonna get scrambled. If hang on, the only way we are bending to Okay, this is what I was wondering. There it is. And then finally, this is a void function. Oh, but it's got an output mesh buffer. All right. It's pretty slow though. We would probably need. Oh boy. Oh boy. Alright, we're alive, we're alive. Let's push a commit here so we don't lose anything. Like, we could bring this down now. Alright, last run for real now. It's been 30 minutes putting another fucking parallel 4 in. We just have to figure out the meshing formula and how to use this table, this lookup table. And I think we just suddenly have like a pretty good mesh generator, and then it's just optimization question. And this should actually be, hopefully, easier to optimize. In fact, this could be a pretty good candidate for compute shader optimization. That would be its own fucking can of worms, but it's possible. Oh, and the LOD levels can come way down, like the distance, because we're using bigger nodes, because the nodes give more geometry per node. Like, obviously not right now, when they're all jacked up. I'm pretty sure this is going to be better. Like, the fact that we're getting more geometry or at, like, shallower levels of the Octree is a really good benefit, even if it's lagging like fuck right now. It's not surprising that it would be lagging like fuck or be unoptimized right now, because we just got it working. We're just got it doing anything. It's not working. Okay, so tomorrow I want to fix the fucking meshing. That's priority number one. Changing defaults. All right.